Welcome to Deep Dive Ortho. Today we're venturing into a topic that's, well, profoundly foundational. It's often understated, I think, yet utterly indispensable to medicine and specifically to orthopedics. We're talking about the enduring role of human cadavers. Joining me is Professor Mo Imam, whose expertise in orthopedics is, frankly, second to none for illuminating this intersection of practice and or fundamental science. We'll be exploring what you might call the curious lives of human cadavers, a phrase sparked by Mary Roach's book title, Stiff. It really makes you think, doesn't it, about the extraordinary ways these gifts contribute. Okay, let's unpack this.
Thank you. It's a really important topic and one I'm glad we're discussing. It truly underpins so much of what we do in medicine and surgery. You called it a silent pillar, and that's exactly right. Much of modern progress is built upon it. And it's not just history. Its relevance is ongoing, vital for everything from basic anatomy to complex surgical innovation. The insights are just invaluable.
Absolutely. It's something that demands, I think, focused attention and real appreciation, especially for anyone in the medical field. Professor, let's start at the beginning, the foundation. How crucial are human cadavers for training medical professionals, particularly in surgical fields like orthopedics? Many of us have spent hours in anatomy labs. But what are those unique insights you get from bisection that, say, digital models or simulations just can't replicate? What's missing?
That's the perfect place to start because orthopedics is so hands-on, isn't it? It's three-dimensional. You're dealing with complex variability. And that's all deeply rooted in cadaveric study. First off, it's the absolute bedrock of anatomical understanding for everyone. GP, orthopedic surgeon, doesn't matter. But the key thing, the unique thing, is the tactile experience. Nothing else comes close.
It's the actual feel of the tissues.
Exactly. You touch, you manipulate real human tissue. You understand its texture, its pliability, its resistance. Think about trying to tell the difference between a nerve and a small vessel on a screen versus actually feeling that subtle, slippery nerve or the firmness of a tendon.
Right, you just can't simulate that accurately.
You really can't. And this hands-on interaction, it cultivates this deep appreciation for layers, for fascial planes, for how nerves and vessels relate to everything else. You learn the gritty feel of bone, the smoothness of cartilage, the stretch in a ligament, the give of muscle. It's visceral.
And for an orthopedic surgeon navigating complex areas.
It's paramount. Absolutely critical. We're often working in tight spaces near vital structures. Damaging something can have huge consequences. So understanding that precise spatial arrangement, bones, joints, muscles, nerves, isn't just helpful, it's fundamental for safety and effectiveness. That deep spatial and tactile sense, it's built through this work. It reduces risk significantly. It builds a sort of surgical intuition, if you like.
That makes complete sense. And what about the variability? You mentioned digital models can be quite idealized.
That's another crucial point. Digital models often show a perfect static anatomy. Cadavers show reality. You immediately see the vast range of normal anatomical variations. A nerve might run slightly differently. An artery might branch unexpectedly. Muscle attachments can vary.
It happens all the time in practice.
Constantly. So cadavers reinforce that lesson. Every patient is unique. You can't just follow a diagram rigidly. You learn to be adaptable, to think on your feet, to anticipate and manage these variations safely. That's a vital lesson for any surgeon, especially in orthopedics. It directly impacts patient outcomes.
So it's about feeling, understanding physical properties, and crucially, internalizing that inherent human variability. It's much more than just memorizing diagrams. Beyond that foundational knowledge, you also mentioned it's an unparalleled surgical training ground. Can you expand on that? How do residents and even experienced consultants use cadavers to really hone their skills? The no-risk aspect must be huge.
Oh, absolutely huge. The cadaver lab is the ultimate training ground for procedural skills. Indispensable. Think about something like a total hip or knee replacement. On a cadaver, a trainee can practice every single step, repeatedly. The precise bone cuts, getting the alignment right, sizing the components, preparing the bone, impacting the implants.
And getting the soft tissue balance right, which is key.
Exactly. That's crucial for function. And they can do it over and over, building that hand-eye coordination, that spatial awareness without the immense pressure of a live patient. They can make an incision, find their landmarks, try an approach, step back, think, okay, how can I do that better? And then try again.
What about something more intricate, like spinal surgery?
Spinal fusions are a perfect example, practicing laminectomies, discectomies, placing pedicle screws and rods, all while being acutely aware of the spinal cord and nerve roots nearby. A millimeter matters there. And the cadaver lets them feel different bone qualities, dense cortical bone versus softer, maybe osteoporotic bone, which changes how you drill, how you place screws.
And fracture fixation, plates and screws.
Same principle. They can practice different approaches to get to the fracture, learn how to reduce the fragments, put them back together correctly, and then apply the plates or nails. They feel the biomechanics. They apply a compression plate and actually feel the fragments compress. They insert a nail and appreciate the stability it offers. It's tangible learning.
Arthroscopy too, I imagine, working in those small joint spaces.
Definitely. Practicing meniscal repairs, ACL reconstructions, rotator cuff repairs. It involves learning portal placement, navigating with the camera and instruments, maintaining vision, performing precise repairs with tiny tools. It requires a unique dexterity. And that no-risk environment you mentioned is the critical part. Trainees will make mistakes. It's unavoidable, part of learning.
Better there than in the OR.
Infinitely better. They can learn from those mistakes, understand the consequence of a slightly misplaced screw or accidentally nicking a small nerve without harming a patient. They correct their technique, get guidance, perfect their approach. It builds confidence, dexterity, muscle memory, spatial awareness. It really is that comprehensive learning experience, forging theoretical knowledge into practical mastery. Utterly irreplaceable for producing competent, safe surgeons.
That idea of a safe space to fail and learn, not just observe, sounds absolutely fundamental. It really underlines how cadavers bridge theory and the complex, variable reality of actual surgery.
Precisely. It's the ultimate bridge. Textbooks give you the ideal map. Cadavers give you the real territory with all its variations. As we said, nerves take different paths, vessels branch differently. Encountering this firsthand forces you to adapt. It trains your eye, your hand, to anticipate, identify, and manage this variability safely in the operating theater. It builds respect for that individual anatomy.
Okay, so the foundation in training is undeniable. But let's push beyond that. This is where it gets really interesting, as you said. How do cadavers actually drive orthopedic science forward? Foster innovation? How are they instrumental in breakthroughs, new implants, new surgical techniques, even just understanding injuries better?
Right, this is where their curious lives expand beyond individual training to impacting research that helps everyone. Cadavers are absolutely critical for biomechanical research. This is where we study the mechanical properties of bone, joints, ligaments, tendons. We apply forces, loads, simulating real-life activities.
Like walking, running, or even falls.
Exactly. We can apply those forces and see how tissues respond, where they might fail, how they behave under repeated stress. We measure it. It's tangible data from real human tissue. And this research is crucial, absolutely crucial for designing, testing, and validating new orthopedic implants.
Things like hip and knee replacements.
Perfect example. Before a new hip or knee design goes anywhere near a patient, it's rigorously tested on cadaveric bone. Engineers and surgeons work together. They test how load is distributed across the implant, look for stress points where it might fail, simulate wear patterns over millions of cycles.
Millions.
Wow. Yes, using machines that mimic years of use. They assess the fatigue life of the materials. The goal is to ensure that implant will last decades under normal daily stress.
And for things like spine implants or fracture fixation.
Same idea. We use cadaver models to see how well spinal instrumentation stabilizes the spine, how plates and screws hold a fracture, how load is shared between the implant and the bone. We check for potential loosening or breakage under realistic conditions. This preclinical validation is non-negotiable for safety and efficacy. It's the closest we get to predicting real-world performance safely.
So it's not just computer modeling, it's actual physical testing on human tissue under simulated real-world conditions. That must give invaluable feedback for refining designs. What about developing new surgical techniques, particularly minimally invasive ones?
Again, cadavers are the primary platform. Before a surgeon attempts a new, less invasive approach on a patient, maybe for spinal fusion, or a complex arthroscopic repair, it's developed and practiced meticulously on cadavers. We can map out the anatomical corridors needed for instruments, test different tools, use navigation systems, and really assess if the new approach is feasible and safe. The aim is always to minimize tissue damage, reduce blood loss, speed up recovery for the patient.
Can you give an example?
Sure. Think about the direct anterior approach for hip replacement. It aims to spare muscles for faster recovery. That approach was extensively worked out on cadavers first. Surgeons perfected the incision, the muscle-sparing planes, how to access the joint safely, how to place retractors without damaging anything vital.
Right, refining every step.
It's exactly. Or advancing complex arthroscopic knee reconstructions or shoulder repairs. You need cadaver practice to master portal placement, instrument handling in that confined fluid-filled space, executing precise repairs using magnified vision. It even applies to robotic-assisted surgery. Testing the robot arms, their precision, how they interact with tissue is first done on cadavers. This ability to trial, troubleshoot, adjust in a controlled setting is what drives surgical innovations safely forward.
It's fascinating, especially for those minimally invasive techniques where precision is even more critical. And what about understanding injury itself? Trauma research.
Indispensable there, too. For understanding the precise mechanisms of musculoskeletal injury, this is fundamental for trauma care. In the lab, we can simulate traumatic events, specific impacts, falls, rotational forces, like you might see in sports, car accidents, or falls in the elderly. We apply these to cadaveric limbs or spines and study exactly how the injury occurs. How does that force cause a spiral fracture? How does that stress rupture a ligament? What's the sequence leading to a dislocation?
You can actually see it happen.
Yes. Using high-speed cameras, sensors, force transducers, we capture the whole injury process. And that knowledge directly informs injury prevention. If you understand how an impact causes a fracture, engineers can design better protective gear helmets, pads, safety equipment, even car safety features.
Like seatbelts and airbags.
Precisely. Their design is informed by this kind of research. It also helps clinicians interpret scans better. If you know the typical patterns from certain injury mechanisms, you can diagnose X-rays, CTs, MRIs more accurately. And ultimately, it leads to better treatment protocols. Understanding the injury mechanism helps choose the best fixation, design better rehab, predict recovery. It improves long-term outcomes and quality of life after trauma. It's about treating, yes, but also preventing those injuries in the first place.
The impact is just immense, isn't it? From day one anatomy right through to cutting-edge research and even prevention strategies. Now, that title, STIF, The Curious Lives of Human Cadavers, it hints at things beyond the strictly clinical. Let's explore those curious aspects, Professor. What other, perhaps unexpected ways have cadavers contributed to knowledge and safety, maybe outside direct patient care?
Yes, this is where that unique perspective, like Mary Roach's, really broadens the scope. Cadavers play a vital, often unseen role in forensic science, for example, understanding injury patterns, and that connects directly to things like accident reconstruction. The automotive industry is a prime example.
Crash test dummies.
Well, the sophisticated crash test dummies we use today, the anthropomorphic test devices, or ATDs, are derived directly from cadaveric studies, and sometimes actual cadavers were used, especially historically. By instrumenting them, placing them in vehicles, and conducting controlled crashes, researchers measure the precise forces on the body during impact.
And that data led to better safety features.
Directly. The design of seatbelts, how airbags deploy, crumple zones in cars, even child safety seats, all heavily informed by understanding how impacts cause specific musculoskeletal injuries based on this research. Knowing how a certain impact causes, say, a specific leg fracture or a spinal injury leads to engineering that prevents or mitigates it.
So it's a form of societal preventative orthopedics almost.
You can certainly see it that way. It reduces the burden of trauma on healthcare systems by preventing injuries before they happen. It impacts public health profoundly. And beyond crash tests, forensic scientists use cadaveric data to understand falls, blunt trauma patterns, wound characteristics, helping interpret crime scenes.
It's incredible. Contributing to car safety, something we all benefit from without realizing the research behind it. That really is a curious life beyond the OR. Are there other broader applications, historical ones maybe?
Oh, absolutely. Historically, they were fundamental. Think of Vesalius back in the Renaissance, his detailed anatomical drawings in De Humani Corporis Fabrica, based on actual human dissection, completely revolutionized anatomy.
Correcting centuries of errors based on animal dissection.
Exactly. That shift to empirical observation wouldn't have happened without cadavers. They literally shaped modern medicine's foundations. And even in more niche areas, like military or ballistics research, understanding projectile impacts on tissue to design better body armor. Or aerospace medicine, studying impact biomechanics for pilot safety. The curious aspect also makes us think about the ethics, the societal discussions around body donation. The respect owed, alongside the incredible scientific benefit. It highlights the lengths we go to understand ourselves, protect ourselves. Mary Roach's style, hinted at in titles like Bonk or Spook, is perfect for this. She makes potentially macabre or technical subjects accessible, engaging, thought-provoking. Interesting, not morbid, like that review said. Slightly irreverent, but definitely interesting.
That presentation style is key, isn't it? How important is that slightly irreverent but definitely interesting approach when discussing something so serious, so sensitive? Does it risk trivializing the gift?
I think it serves a vital purpose, actually. It demystifies things. For the public, it makes a potentially off-putting topic approachable, engaging. It fosters understanding and appreciation for body donation. And for us, in medicine, It encourages a broader perspective.
Mm.
It reminds us these aren't just specimens, they are individuals whose final act has profound impact. It brings a human element into a clinical discussion, highlighting the respect and gratitude owed. Roach's inquisitive, accessible style bridges the gap between science and the public, and even within medicine, encourages a more holistic view. It stimulates conversation about the human story behind the science.
Thank you, Professor. The sheer breadth of impact is staggering, really. From the absolute fundamentals to the truly unexpected, the contributions seem almost endless. So, just to recap our deep dive today, we've seen the profound, often unacknowledged contributions of human cadavers. They're essential for foundational anatomical training, for pushing the boundaries of orthopedic innovation in implants and techniques, and even for wider public safety and forensic science. It's this unique mix of scientific rigor, innovation, and crucially inherent respect for the human body that defines these curious lives.
Absolutely. And if we connect that to the bigger picture, it really underscores the enduring legacy of body donation. Its importance for future advances, especially in hands-on fields like orthopedics, is continuous and invaluable. Of course, the ethical considerations are always paramount, ensuring utmost respect, maximizing the value of the gift, balancing knowledge pursuit with profound gratitude. Which I suppose raises an important question for all of us. How do we continue to honor these gifts? How do we maximize the learning from these extraordinary contributions for the sustained benefit of humanity and medical progress? It's a constant responsibility, requiring ongoing thought and innovation in how we approach this irreplaceable resource.
A very powerful question to reflect on, Professor. Thank you. As we finish, let's perhaps pause and consider those silent partners in every surgical success, every discovery, every single advancement in orthopedic care. The human cadavers whose curious lives post-mortem fundamentally shape our ability to heal. If you found this deep dive valuable, please do rate and share the show. My sincere thanks again to Professor Mo Imam for sharing his invaluable insights today. Join us next time for another deep dive ortho.